Before studying pointers, let's discuss these important statements regarding memory and addresses. Each address identifies a single byte of memory. Addresses are binary numbers usually represented in hexadecimal. For example, this one you can see the representation in hexadecimal. When data is loaded into memory, it occupies a certain range of addresses. So this is, for example, data. This is integer variable, and that store it here on these 2 bytes, and the address of these 2 bytes, the first byte address is 3301, the address of the second byte is 3302. So we can say that the address of this variable is 3301 because this is the address of the first byte. So basically the programmer used these names to access these contents, and these are contents of the variable, and the computer access the contents or the data at these bytes using these addresses. Similarly, we can see here this one is probably a float variable. It occupies 4 bytes, first, second, third, and fourth, and the address of this second variable is 3303. So this is the starting address of the first byte of this variable, or the programmer can access the contents of this variable using the name. So when data is loaded into memory, it occupies a certain range of addresses, and these are the addresses. Every variable starts at a particular address, as we discussed these one. Every instruction, statement, or function starts at a particular address. Similar to these variables, the instructions also are stored on these bytes, and they have their own addresses also. A variable is a convenient name for a memory location, and this is convenient to programmers. The address of a variable is the address of the first byte of that variable, as we discussed on the previous slide, and the ampersand sign is the address operator. Pointer declaration is very simple. You need to mention the type of data type, and then space, static, and name of the pointer variable, and then semicolon. So it's very simple. This is an example: integer and static, and the name of the pointer variable is a, and then semicolon. So it declares a variable with a name a of type pointer that hold the address of integer variable. So basically this variable, because this is a pointer variable, it can hold the address of the integer variable. It cannot store the address of a float variable, and it cannot store the address of a character variable. And these are the 2 other examples: float, xyz. So this is the indication that it's a pointer variable. So this is the type of variable, pointer, and this is the name of variable, and semicolon. Similarly, character, and then pointer, and then this is the ali is the name of the pointer variable, followed by the semicolon. So for example, this one, this variable, it can store the address of a character variable. Here on this slide we have a few examples of the addresses. The address of variable 1 is 3301. It's an integer variable because it occupies 2 bytes. So the address is 3301. This is the starting address, the address of the first byte of this variable. The address of the first byte of this variable, variable 2, is 3303. So this is the address of 3303. The address of UETM1 is 3307. It's a character variable because it occupies only 1 byte, so this is the address. The address of this variable, it is a float variable. The address is 3308. Similarly, the address of VN3 integer variable, the address of the first byte is 330C. So this is the address of the 13 variable. The address of CSE underscore 19 is 330E. So this is wrong. We need to correct this. And this is 330E. So that's the address of the CSE underscore 19. And then we have 2 bytes which are free to use the memory location at 3301. This one is free, and 3311, this is also a free location. So these are a few examples regarding addresses and a few variables. We are using the same variables, the one we discussed on previous slides. We have 3 variables, integer variables in this program, and then 2 float variables, 1 character variable. The character variable is stored on UATM1, this one, and this is the ASCII code of capital R. Then we have 5 printf statements. We are displaying the integer value, float value, character value, float value, integer value, and then the address of the integer value. %p is the format specifier to display the address. So this is the contents of the variable 1 integer. So this is the output, and this is the address. You will get a different value here. It depends, and it will be different computer to computer. So this is the float variable, this is the contents 29.005, and then this is the address of the float variable. Again, these addresses will be different on your computer, on your machine, but the value of the variable, you will get the same output. So this is a very simple example, and that's how we access variables through their names. You are already familiar with these simple statements, and we can access the contents of these variables using format specifier. So in this program, we access the contents of these variables using their names, the name of the variables. Now let's try to access the variables using pointers. So this is the dereference operator, or sometimes it is referred as the indirection operator. In this example, again, we have 3 integer variables, and then 2 float variables, 1 character variable. Then we have 2 pointer variables, and we discussed earlier that this is the integer pointer variable, and this is float a pointer variable. The name of this pointer variable is pntr, and the name of this pointer variable is p. So here p, we will assign the address of variable 1. Remember that p can store the address of integer variable, so we can assign the address of this integer, or we can assign the address of this integer, we can assign the address of this integer, but we cannot assign the address of this variable because this one is float and this one is float, this one is character. So this is the integer pointer, this is the float pointer. So for the integer pointer, we are connecting it to the variable 1, so we'll assign the address of variable 1 to p pointer, and we will assign the address, because this is address operator, the address of CSCFT1 will be assigned to pntr. Now this is the very simple statement, and it will show how we access the same contents of the same variable using variable name. So this one is %d, and we are using, or we are accessing the contents of this variable using the variable name. This is the variable name, and the output is 4545. And here we are using the same variable using pointer. 4545, the same contents without using the name of the variable. Instead we use the pointer, because the pointer, this p pointer, it hold the address of this one. So the static here work as the dereference operator. The static in the declaration indicates that this is a pointer variable, and the static here or the rest of the program, it shows that it is the dereference operator. Similarly, in the second statement, you can see that the contents of CSCFT1, we will access the contents of this variable using the variable name, and this is the variable name, and you can see this is the output. And now the second %f, that will be resolved, and the output, this one, the contents will be displayed using the pointer, because p and t are pointer, it hold the address of this one. Let's suppose if we change the this one, the content is this float variable 2 or var2, so the output will be then 29005. So it's very simple statement. The same variable, the contents of the variable, they are accessed through variable name, and here the contents are accessed using pointers. We have three integer variables here, a, b, and c, and the contents of a is 4, the contents of b is 10, and the contents of c is 50. And then we have a pointer variable. The name of the variable is p, and the type of this pointer is integer. So here in this statement, we will assign the address of a to the pointer. In other words, we will connect this pointer to variable a, and using the dereference operator, the output will be 4. Then we will assign the address of the second variable or the b variable to the pointer, and then using dereference operator, the output will be 10. Then we will change the address, and now the address of c will be assigned to the pointer, and now the output will be 50. As you can see that this statement, the same statement here and here, they give us three different outputs, because here the pointer points to variable a, here the pointer points to variable b because of this, here the pointer points to variable c because of this address. Returning more than one variable from a function. Actually, we will not return more than one variable from a function, but we will send three addresses to this function, and this function will make changes directly on those addresses. So that's how we say that we are returning more than one variable. So this is the main function. We have three variables here, a, b, and c. The contents of a is 12, the contents of b is 20, and 30 is assigned to variable c. Then we have three integer pointers. The name of the first pointer is p, then we have q pointer, and then we have third one r. So we have three pointer variables, and the type of these pointers is integer. So the address of a will be assigned to the pointer p, the address of b or the second integer variable will be assigned to pointer q, and the address of c or the third variable, this one, its address will be assigned to the third pointer, and this is the name of the pointer. Then we will print the values. So here in this statement, we are printing simply the contents of these variables using the variable names. These are the variables names, so this will be the output. The value of A is 12, B is 20, C is 30, the same. It's very simple. Then we are sending the addresses to the function cf1. So this is the definition of cf1 function. This is the name of the function, and this function can receive three pointer variables. The first pointer will be received at this x, the second pointer or the address that will be received on this pointer, the third value will be received on this pointer. So if these are the pointer variables, that means that these variables can hold the addresses, and here we are sending the addresses because P is holding the address of A, Q is holding the address of B, R is holding the address of C. So when we send the arguments to the CF1 function, or when we call this function, the address of A, which is stored on P, that will be stored onto the X pointer. The address of B will be stored on this pointer. The address of C, which is stored on R, that will be stored on Z pointer. So the dereference operator, or the contents of X, or the variable which is pointed by this pointer, that will be incremented by 10. 100 will be added to the variable which is dereferenced by this pointer, and 1000 will be added to the contents of the variable which is referenced by the Z pointer. And when we print again the values of the ABC, so you can see that now the values of ABC, the value of A is now 22, the value of B is now 120, and the value of C is 1030, because this is the function which have changed the contents of these variables. In this example, we will use a pointer variable to access the elements of the array. We have 5 integer variables in this array: 10, 15, 20, 30 and 40. Then we have a pointer variable. The name of the pointer variable is P. In this statement, we will assign the address of the first element to the pointer, and when we print the using the dereference operator, the contents of the first element will be displayed because the pointer is connected to the first element of the array. And this, in the second printf statement, you can see that the dereference operator is pointed to the first element, the address of the first element plus 1, so that means the next element, so the output will be 15, and then the first element plus 4, that means plus 4 elements, so 1 2 3 4, so the contents of last element will be displayed. So here you can see that by accessing the first element of an array, all the elements can easily be accessed. Pointer statements. The address operator ampersand accesses a variable's address in the memory. Addresses can be stored in suitably declared variables, which are called pointers. The steric symbol is called dereferencing operator. The address operator placed in front of a variable's name refers to the address of variable. For example, ampersand variable means the address of variable 1. The dereference operator, steric, or sometimes the indirection operator, it means the value of variables pointed to by, or contents of operator. The steric symbol, when followed by a pointer, means the variable whose address is stored in. For example, static CSCFT means the variables whose address is stored in CSCFT, the name of variable. When a pointer variables, the content of variable that are finally obtained are always found by first going to the pointer for an address. The address contained in the pointer is then used to get the variable stored value. Pointer must be declared before they can be used to store an address of declared variable. When declaring a pointer variable in C++, it requires specifying the type of variable that is pointed to. For example, integer static variable 1 or float static variable 2, or the one we already used in previous slides. To understand pointer declarations, reading them backward is helpful. Start with the indirection operator static and translate it as the variables whose address is stored in, or the variables pointed to by. So these are different conventions which you can use for reading or understanding the pointers.